My name is Alex Lindsey. I'm an associate professor in the Department of Horticulture and Crop Science in the College of Food, Agricultural, and Environmental Sciences here at Ohio State University. And I'm really happy to be able to be doing research here at the Northwest Agricultural Research Station. We have a few main projects that we're focusing on for this growing season. The first of which is looking at corn and its response to flooding and how nitrogen application practices interact with that response.
I'm looking at the key inputs like fertilizer, how it's affected by flooding, and to minimize the impact of flooding on the yield of corn. That's important because with the climate change, it became more common, flooding events, and there's a damage for farmers in general, over 7 billion, it was estimated by some studies, and reduce the yield of corn for more than 30%. Specifically with my project, we have 3 different angles. The first one, we are looking to cover crops, how that impacts the water cycle. And with that, we hope cover crops will have a positive effect on corn yield and corn growth. We also have one that's with different end sources. We're using synthetic fertilizers, organic fertilizers or biological fertilizers, and nitrogen stabilizers. And here where we're standing is the third angle or the third aim that we have, where we have different flood regimens, where we have 0 days, 3 days, and other 3 days with 2 days of break and another 3 days of flooding. And this to simulate the natural occurrence of flooding. And specifically here behind me is a 3 days of flooding. I'm in a treatment where you did not apply pre-planting fertilizer, but apply a side dress. And behind me is like no flooding, and we even can see the difference where you have like a smaller corn compared to a higher corn. So by the end of this project, we hope to understand how floodings impact corn, if you can keep the productivity, and even develop a post-flood nitrogen application management. Thank you very much.
The second research area we're really focusing on is agronomics of a new potential oilseed crop for sustainable aviation fuel called oilseed pennycress. Oilseed pennycress has really high oil content, and there's new lines that are being developed that have low uric acid to improve feed quality and usability in other arenas. And so we're looking at ways we can grow this new crop in Ohio, and we're using the Northwest Research Station to really highlight a lot of that work. So our novel oilseed pennycress here, this is a wild type version that's been improved beyond what you'd find normally growing in your field as stinkweed or Frenchweed or just field pennycress. But the color of the seed's pretty much the same. Seed size is a little bit bigger, but this has been improved to reduce shattering to actually allow for feasible harvest and extraction for oil content. Now this is an improved variety. There could be some of these that end up hitting the market at some point, but what companies are really working on is what's called a golden pennycress. And so this is the same species, but based on selection processes and identification of novel biotypes, they found this yellow seeded version. The seed's a little bit smaller, but it has the same qualities as the other from an oil perspective, but there's less fiber and less acid, making it more attractive for use in the oilseed market. So this is the type of experimentation that we're doing here at the Northwest Research Station on this particular crop. My student Nasib Koirala is working on this crop as well, but using some novel seed pelleting practices, and he can tell you a little bit more about that.
Hi, I'm a master's student currently studying at Ohio State University, and I'm currently studying the oilseed pennycress for its agronomic characteristics. And we've done the lab work, and we've seen that the inclusion of gibberellic acid and the pelleting process in the pennycress seeds will enhance its germination. Now we want to test it in the field conditions, and we are trying to test it with 2 different varieties of the pennycress. One is the wild type and another is the golden pennycress, and we're starting the planting this fall from the mid of this September, and we are hoping that our treatments would improve the establishment and germination of the pennycress in the field as well. Thank you.
The research that we're doing up here at the Northwest Station wouldn't be possible without the funding support that we've received for these projects. The oilseed pennycress work that we've been talking about with the pelleting and the different agronomic traits is funded through the Sustainable Agricultural Systems Grant Program through USDA NIFA. And the flooding work that we've been working on up here is funded through the AFRI Foundational Program, also through the USDA NIFA program. So without the funding support, we wouldn't be able to do the projects that we're doing up here today.